This tutorial is about sizing steam distribution piping in industrial applications. This is Mo Sabet. I'm a registered mechanical engineer with over 30 years of experience in HVAC and utility systems. Sizing pipe for saturated steam is super easy. Let's go to Google and search for a website called pipecalculators.com. I will leave the link for the site in this YouTube tutorial. If I click on the link, the Engineering Calculators website will pop up. This site has a lot of different engineering calculators, very unique, handy and very useful. The link can be easily added to the computer and/or smartphone. One of the calculators we are going to look at today is pipe sizing for saturated steam. If I click on the link, the calculator page pops up. The calculator is good and accurate for carbon steel scheduled 40 pipe and for saturated steam pressure between 1 psig and 2880 psig. And because saturated steam pressures and temperatures are related, these limits in terms of temperature would be between 212 degrees Fahrenheit and 690 degrees Fahrenheit. The calculator can be used in two different units, IP, which is inch-pound, and the other one SI, which is the metric units. In this example, I will select the IP units. In order to calculate the pipe size for saturated steam, three inputs are needed. The first input would be the saturated steam pressure or temperature. Here it shows in letters P and T. Again, because pressure and temperature are related for saturated steam, I'm going to use the pressure here. And I'm going to assume that I want to size the pipe diameter for steam at 130 psig pressure. The second input is the steam flow rate. For example, how much pounds per hour of steam we want to run through the pipe. I am going to assume that the flow rate is 15,000 pounds per hour of steam. The third input would be either the steam velocity through the pipe in feet per minute or the steam pressure drop through the pipe in psi per 100 feet of pipe. Here I use the steam pressure drop for this example. Let's say we want to size the pipe for 3 psi per 100 feet of pipe pressure drop. Using these criteria, per calculated output, a 5-inch diameter pipe is required. The velocity of the steam through the pipe would be 5,604 feet per minute and the pressure drop 1.15 psi per 100 feet of pipe for this setup. As you can see, the pressure drop is less than our input number. This is due to the selected pipe diameter size. The pressure drop would not be exactly the same as the input because pipe sizes are standard and they are limited to the available diameter sizes in the market. If we use a 4-inch pipe instead of 5-inch, then the pressure drop will be more than our input of 3 psi per 100 feet. This calculator is very flexible, and in addition to the application of using it for sizing the steam pipe diameter, it can be used to analyze a steam pipe situation. For example, let's say we have an existing steam pipe and we know the pipe diameter size and we want to know how much steam can run through it at a certain steam velocity or at a certain pressure drop. This calculator can help to easily analyze the situation. Let's say we want to determine the steam flow rate for a 6-inch diameter pipe with steam running at 8,000 feet per minute velocity in a steam system operating at 100 psig saturated. Let's change the inputs. The calculated flow rate would be 24,789 pounds per hour of steam. The pressure drop in this situation would be 1.5 psi per 100 feet of pipe. So this is a very useful calculator and can be used either for analyzing the existing systems and/or designing a new system. For new systems, we can analyze and look at different situations and see what the outcomes would be. There is a note at the bottom of this calculator that says, "See recommended pipe sizing criteria in homepage." If we go to the homepage, there is a link to the recommended pipe sizing criteria. Clicking on the link, the page pops up. On this page, there are separate sections with recommendations for different piping and utility systems. Section 1 provides recommendations for pipe sizing for the city water. Section 2 is for sizing the drain pipes when under pressure. Section 3 is for pipe sizing for hydronic systems like chilled water, heating hot water and cooling tower. Section 4 is for a steam and a steam condensate pipe sizing. Section 5 is for compressed air piping. And Section 6 is for natural gas piping. Going back to the steam and steam condensate piping section, I like to get your attention to the last two recommendations. It says verify the steam velocity in piping not to exceed 8,000 feet per minute. This is to have a pipe size that will give us a quiet operation with no objectionable noise. The last recommendation here is, determine the pressure drop for components other than piping, for example, control valve, strainer, etc., and verify delivered steam pressure to the end user is adequate. As for other recommendations for sizing steam pipes, if the project has requirements and criteria to be followed for pipe sizing, they must be used. If not, then there are these recommendations that can help with pipe sizing. These recommendations are based on ASHRAE Fundamentals 2017 and uses different pressure drop for steam at different operating pressure. I hope this tutorial is useful and you benefit from it. If you have any comments or questions, or if I can help you with solutions for these type engineering systems, please let me know by leaving comments here. I will get back to you. Thank you for watching.